today's problem from inequality, and the problem is if a1, a2 to an be all positive real numbers and a1 into a2 to an, this is given by k to the power n, where k is also a positive number. Prove that 1 plus a1, 1 plus a2 into 1 plus an, this is greater equal to 1 plus k whole to the power n. Okay, and to prove this result, we use the result, very popular result, which is known as am greater equal to gm, that is arithmetic mean greater equal to geometric mean. And this state that if we take n number of positive number, that is a1, a2 to an, and the arithmetic mean is this summation a1 by n. Summation a1 means a1 plus a2 to an, right, by n greater equal to a1 into a2 into an whole to the power 1 by n. Okay, because there be n number, so multiply it first and then raised to the power 1 by n taken. Okay, and this is known as am greater equal to gm. Now for this problem, we first write the left side. The left side is 1 plus a1 into 1 plus a2 to 1 plus an. If we multiply this result, we get first term is 1, the second term we write here the sum of a1, a2 to an. Okay, because we multiply a1 with 1, 1 and 1, then we get a1. If we multiply a2, 1, 1 and n minus 1 number of 1, then we get a2, and getting the result as second term, this is summation a1. Okay, and now the third term is taken as summation a1, a2. Okay, we take two term out of n term, which are a1, a2 to an, and so on. The fourth term is summation a1, a2, a3, and the last term is a1, a2 to an. This is the product of this expression. Now we use this result, and this result. Here we use am greater equal to gm. How to use am greater equal to gm in all this result? We write first, here already write that summation a1, this means the second term, this is greater equal to n into, and this is given by k to the power n, right? a1 into a2 into an, this is equal to k to the power n. So we get n into k to the power n whole to the power 1 by n, and this is summation a1, so we get summation a1 greater equal to, this is k, and we get here n, we write it nc1. Okay, we get the first result. Here we use in place of summation a1. For summation a1, a2, that is we take two term at a time out of n term. Here we get summation a1, a2 by, this is nc2, because there are nc2 term. If we take two term out of n term, so am is this, and gm is given by a1, a2 to an whole raised to nc2, but this is to the power also n minus 1 here. How get n minus 1 as this to the power? Because when we take this type of term, and if we multiply all this type of term, it is easily clear that a1 appears in the product n minus 1 times, a2 appears in this product n minus 1 times, and similarly all the term appears in this product n minus 1 times. Okay, so we take here the power n minus 1. Now we put Now we put this value, that is the value k to the power n. So we get this is summation a1 a2 greater equal to nc2, and this is k to the power n whole to the power n into n minus 1 by nc2. nc2 means n into n minus 1 by 2. Sorry, this is not n. Now calculating, we get nc2, and this is k to the power n into n minus 1 by n into n minus 1 by 2, and this is nc2 into k to the power, this is 2. Okay, so we get for this term. And similarly, by using an greater equal to gn, we get this term. We apply directly here, greater equal to, we unchange the first term here, and for the second term we write this result, this is nc1k, so we write nc1 into k. For this term we write nc2 into k square and nc3 into k cube, and similarly we get this is ncn into k to the power n. Okay, and clearly this is the binomial series of 1 plus k whole to the power n. So our proof is that this is the left side and this is the right side. Okay, so this is proved. And for the second problem, here it is given that xi greater than a greater than 0. Okay, so since xi greater than a, so all of x1 minus a, x2 minus a and xn minus a all are greater than 0. Okay, and this is taken as, if we take this is capital A1, this is capital A2 and this is capital AN, then we get the similar result as in 1. This is A1, A2, AN, this is equal to k to the power n. Okay, and we have to prove this result. Now for the second problem, we write first left side x1, x2 to xn, right? And now we write this x1 as a plus x1 minus a, right? A plus x1 minus a, and the second term is a plus x2 minus a, and the last term is a plus xn minus a. Now we put capital A1 in place of x1 minus a, capital A2 in place of this, and capital AN in place of this. So this expression can be written as a plus capital A1, this is a plus capital A2, and so on a plus capital AN. Right? Now multiplying all this factor, we get a to the power n plus, and this factor is given by a to the power n minus 1 into summation capital A1. Okay, plus a to the power n minus 2 into summation A1 A2, and so on. The last term is A1 A2 to AN. There is no small a. Okay, and now putting the similar result as in case 1, we get this is greater equal to a to the power n plus a to the power n minus 1 into nc1, this is k, because here given that a1 a2 an this is equal to k to the power n. By using the similar result, here we put nc1 into k. For the second term, we get a to the power n minus 2 nc2 k to the power 2, and similarly a to the power, this is given by, sorry, we write this is k to the power n, and we write here ncn, because ncn means 1. Okay, and this is nothing but a plus k whole to the power n. This is the binomial expansion of a plus k whole to the power n. Okay, so here the left hand side of our given or required result, and this is the right hand side. Okay, so we proved the second result also. Right, very simple problem but interesting problem of inequality. Thank you for watching.